What's up, guys? Today we'll be doing Catholic High School Prelim Examination 2024, Paper 1, Booklet A. Alright, we're gonna jump right in. I will not be doing all the questions. Those that are straightforward, I'll just skip them. Alright, jumping right in, question 1. Which of the following is the same as 5080 cm? Before we start, we want to know that 1 meter is equals to 100 cm. From here, we can see that the decimal is bounced 2 times from cm to meters. So likewise, we want to do the same for our 5080 cm. We're going to bounce the decimal 2 times, and that will give me 50 meters. And what we are left with is 80 cm. And therefore, this is the answer for question 1, number 4. Alright, moving right on to question 2. How many 7s are there in 2 whole 4/7? First thing we need to do is to change our mixed number into an improper fraction. How do we do that? First, we need to take the whole number multiplied by the denominator, which is 7 over here, and that would give me 14. Next, I want to add 14 to the current numerator, and I will have 18. So my improper fraction will be 18/7, and this 18 is the answer for question number 2. Alright, next question. Question 4. Right, the figure below shows a cube. Which of the following is a net of the cube? Alright, this question requires you to do a bit of visualization. But before we start, what I want to do is to number them. Alright, to number each side of the cube so that y'all can see clearly where my side is going. So I'm going to label this as 1, 2, 3, 4, 5, and 6. First thing, I want to draw the number 1. I would like for y'all to imagine that this net is placed on the floor. Alright? And then we are going to stack up the sides to see if they form my cube. Okay, so if I have 1 on the floor like that, my 5 would definitely be folded up to be like that, right? Alright, so my 5 will be over here if you can see it. And 6 will definitely be at the back over here. Okay, so we have 3 sides of the cube already. Now, what happens to 2? 2 will be folded up to cover the front side. Alright, and 3 will be at this left side over here, if you can see it clearly. But 4 will actually be left behind the cube, like that. So, number 1 is clearly not my answer. Alright, I'm going to move on to the second one. Okay, for this, I'm going to label this as 1, 2, 3, 4, 5, and 6. So, likewise, 1 starts at the ground. Okay, 1 is here. 2 will be on top. When 3 folds in, 3 will be over here. Right? Now, 4 will be folded up to be on this side. And 5 will be at the front. So, it will be on top like that. And there you have it. This is a cube. So, my answer for this question is number 2. But just to be sure, I'm going to show you that the rest will not make a cube as well. Alright, so moving on to option 3. 1, 2, 3, 4, 5, and 6. Starting from on the ground with number 1. 4 will be on the side, down here. 3 over here. 2 at the back. 5 over here. And you realize that 6 is right beside 5. So 6 will be sticking out like that. And nothing is covering the top. Right? So 3 cannot be my answer. And lastly, number 4. Likewise, 1, 2, 3, 4, 5, and 6. Alright, 1 to be on the bottom, 2 will be at my side, 3 will be at my other side, and 4 would be on top. Right? But now 5 is behind, and 6 would be on top as well. Right? So it will clash with number 4, and therefore number 4 is not my answer. So the answer for question number 4 is number 2. Alright, moving on to question 5. Which two lines are perpendicular to each other? How can we find out if two lines are perpendicular? Okay, we want to bounce on the vertical lines and then also on the horizontal lines and see if for two lines they match up. So let's look at AB first. For AB, we have 1, 2, and 1. Alright, let's look at AD right now. Okay, 1, 2, 3. 1, 2, 3, 4. Okay, so we have 3 over here, 4 over here. For AB, we have 2 and 1. For DC, we have 1 on this side, 1, 2, 3 on this side. Alright, but for BC, let's look at it. We have 1, 2, 3, 4, and 1, 2. We have 4 and 2. Alright, but what I want you to pay attention to, right, is that you notice that BC meets at a point in the grid over here. So what I want to do is to look at this. So it's actually 2 and 1, just like AB. Can you see that? And therefore, my answer is AB and BC, which is number 1. And that is my answer for question 5. Alright, quickly moving forward to question 8. The line graph shows the amount of rainfall over 5 months. The amount of rainfall is not shown on the scale, so we do not know the values of these points at the moment. Let's look at the question. From which month to the next was the increase in rainfall the greatest? So how can we tell if the increase is the greatest? We have to look at the number of increments from one month to the other. Alright, first things first, I want to cancel out March to April. Why? I'm going to cancel this one out. Because it's not an increase, it is a decrease. The rest of them are increasing. So let's look at January to February first. Let's count the number of increments they have from these 2 months. Alright, we have 1, 2, 3, 4, 5, 6, 7, and 8. So between January and February, we have 8. From February to March, we have 1, 2, 3, 4. 4 over here. April to May, we have 1, 2, 3, 4, 5, 6, 7. And they are asking us from which month to the next was the increase in the rainfall the greatest. So therefore, my answer is January to February. And the answer to question number 8 is number 1. Alright, moving on to question number 9. Looking at this question, I can tell that this question is a time question. Alright, and whenever we are faced with a time question, what I want to do is to list down my ABCDs. Okay, A being always make it whole. Alright, B is to break it up. C to cancel out. And lastly, D to draw a timeline. Alright? Okay, let's read the question together. Charles and Danny started running a marathon at 5:20 a.m. So we know their start time, right? Their start time is 5:20 a.m. Moving on to the next sentence. Charles was 20 minutes slower than Danny, who completed the marathon at 9:05 a.m. Right, so who completed the marathon at 9:05? Was it Charles or Danny? Alright, Danny completed the marathon at 9:05 and Charles was 20 minutes slower than Danny. When you are slower at doing something, do you finish it earlier or later? Right, the answer is later, right? Instead of 9:05, Charles actually finished his marathon 20 minutes after 9:05 a.m. So that would be 9:25 a.m. Alright, now let's look at the question. How long did Charles take to complete the marathon? Alright, so we have our timeline over here. Now what we want to do is to break it up. Alright, we're not just gonna count it all the way. We want to break it up into hour intervals so that it's easier for us to count. So the first hour, right, would be 6:20 a.m. Next hour, 7:20 a.m. Next one would be 8:20 a.m. Alright, another hour. And then lastly, the last hour would be 9:20 a.m. Alright, and you know that from 9:20 a.m. all the way to 9:25 a.m. is just 5 minutes. And therefore, Charles completed the marathon in 4 hours and 5 minutes. And your answer for this question is number 2. Alright, moving on to question number 10. In a school, the ratio of the number of boys to the number of girls is 1:2. Alright, we're going to list that down over here. Boys is to girls is 1:2. Moving on to sentence number 2. The pie chart shows the different ways boys and girls go to school. Alright, now let's look at the question. What is the ratio of the number of boys who walk to school to the number of girls who walk to school? Before tackling this question, we want to direct our attention to the pie chart and to know that this is what we need to focus on, right? The boys and the girls who walk to school. Let's look at the boys first. You can see that there is a 90-degree mark at the boys who walk to school. Right? Whenever we see 90 degrees, we immediately know that it is 1/4 of the total circle. So the boys who walk to the total boys is 1:4. Now let's look at the girls' pie chart. The girls who walk to the total number of girls is 20:100 because the girls who walk is 20% and the total pie chart is 100%. Now what do I want to do? I want to simplify my girls ratio by dividing each side by 5. Alright, so I will have 20:4. From here, I want to times 5 on this side so that I get 5:20. Right, now that you see that my total boys and my total girls are the same, am I right? But that is not what I want. I want them to be 1:2, right? So I'm just going to leave the total boys to be the same. But the total girls, what I'm going to do is to multiply by 2 once again. Alright, multiply by 2. So I'll have 40:8. And there you have it. The boys who walk to the girls who walk is 5:8. And the answer for this question is number 4. Alright, next question. Question 11. Here we have an angles question. Along the way, I'll be using certain concepts and writing them down at the side. So please take note and memorize them. Alright, jumping in. In the figure, ABCD is a square. Alright, first I want to label my square. That is my sentence number 1. Alright, moving on to sentence number 2. It says that AD and DF are the same. Likewise, I want to label them. AD and DF are the same. What does that mean? It means that triangle ADF is an isosceles triangle with 2 lengths that are the same and 2 angles that are the same as well. Alright, moving on to the next part. It says that angle ADF equals to 58 degrees. Now, what is the question asking? It says find BEF. I'm going to highlight BEF in blue so that everyone can see what we are looking for. Okay, how do we begin doing this question? I want to first direct our attention to the isosceles triangle ADF. If angle ADF equals to 58 degrees, I can find angle DFA by taking 180 degrees minus 58 degrees and dividing the whole thing by 2. Why? Because first concept, the sum of angles in a triangle adds up to 180 degrees. So what will I get here? I will get 61 degrees. So now I know that my angle DFA is 61 degrees and my angle DAF is also 61 degrees. Next, knowing that ABCD is a square, my angle DAB has to be 90 degrees. And if angle DAF is 61 degrees, I can find angle FAB. Angle FAB would just be 90 degrees minus away 61 degrees. And that would give me 29 degrees. Knowing that ABCD is a square and that I have one line from one end of the square all the way to the other end of the square, I know that the angles will have to be 45 degrees. From here, what can I do? I can find angle AEB by taking 180 degrees, subtracting away 29 degrees and 45 degrees. And that would simply give me 106 degrees. Using another color to show my 106 degrees, this will be my 106 degrees. Now to introduce you to another concept, the sum of angles in a straight line also adds up to 180 degrees. So from here, can you see that AEF is a straight line? Using the yellow color, I'm going to highlight my straight line. Alright, knowing that that is a straight line, do you think I can find angle BEF? I can. How do I do that? Angle BEF equals to 180 degrees minus away angle AEB, which is equals to 106 degrees, and that would give me a grand total of 74 degrees, and that is your answer for question number 11. Alright, moving on to question number 12. Let's jump right in. Ivan had 30 fewer sweets than Peggy at first. This is sentence number 1. Alright, when I see a word like fewer, I immediately want to pay attention to this concept over here called comparison. Alright, whenever I see this, I want to draw a model. Alright, so Ivan will have 30 less than Peggy. Alright, moving on. We're going to read sentence number 2. It says that after he gave some of his sweets to Peggy, he was left with 28 sweets. So some of these is going to go to Peggy over here. So after giving some to Peggy, what he was left with is 28 sweets. That is sentence number 2. Now let's look at sentence number 3. Alright, Peggy had 3 times as many sweets as Ivan in the end. Another keyword that we see over here is 3 times. So we know that this question has the concept of multiples as well. So now we know that Peggy has a total of 3 units and that this 28 over here that Ivan is left with is my 1 unit. So moving on from here, if I know that my 1 unit equals to 28, can I find what 3 unit is? 3 unit would just be 28 times 3 and that would give me 84. Now, knowing that 3 units, which is what Peggy has now, is equivalent to 84, I want to do some mirror imaging. I can see that there is 1 unit over here. There is the amount that Ivan gave to Peggy, which I am going to label as X, and the same amount that Ivan gave to Penny. So I have two x's over here. So I can see that my 84 consists of 1 unit plus 2x and 30. Alright, I'm going to replace 1 unit with 28 that we found over here. Okay, 28 plus 2x plus 30. Right? So now if I want to isolate my 2x, it's going to be 84 minus 28 minus 30. And that would simply give me 26. Right? And then can I find x, which is the amount that Ivan gave to Peggy? It would just be 26 divided by 2, and that will give me the answer of 13. And this is your answer for question number 12. Okay, next question. Question 13. We have another angles question. Alright, so let's look at what it says. Figure 1 shows a rectangular paper. It is folded along the dotted line AB to form Figure 2. Alright, let's look at the question below. Which of the following statements are or is true? Let's look at statement A. Angle C plus angle D equals to 90 degrees. Looking at figure 2, I can see that these two lines are straight lines. And when I have two straight lines that intersect, I know that these two angles over here are the same. Why do I know this? Because of this concept. Vertically opposite angles, okay, are always the same. Whenever I have two straight lines that intersect together, these two will be the same. These two will be the same. So knowing this, I have another angle C over here. And the next concept I want to use is the sum of angles in a triangle. It adds up to 180 degrees. I'm going to direct our attention to this triangle over here. Knowing that this corner is 90 degrees and the sum of this 90 degrees plus C and D is equals to 180, C plus D has to be equals to 90 degrees. Statement A checks out. It is true. Now let's look at statement B. The area of figure 1 is less than the area of figure 2. Right off the bat, I know that this is false. Why? Because when you fold a piece of paper, there is actually an area that has an overlap, meaning the surface area is lesser. Therefore, this is definitely not true. Now looking at statement C, both figure 1 and figure 2 have at least a line of symmetry. Knowing that figure 1 is a rectangle, drawing a line straight down the middle from both sides will give me lines of symmetry, right? And looking at figure 2, if you were to draw a line like that, can you see that both sides are actually the same? So this is true. And therefore your answer is A and C only. Number 3 for question number 13. Quickly moving on to question 14, we have a circles question over here. Let's read the question. The figure is made up of two identical quarter circles and a square. I am going to highlight the quarter circles in blue and the square in yellow. Okay, moving on to sentence number 2. It says that the length of the square is 7 cm. The properties of a square is that all sides are the same. So we have 7 cm on each side over here. And we can see that one side of the square is in contact with one side of the quarter circle, which is also the radius. So therefore, we know that the radius of our quarter circles are 7 cm as well. Moving forward from here, we want to read the last part of our question, which is, what is the perimeter of the figure? Alright, now they are looking for the perimeter. Now I want to find the perimeter of a quarter circle, just the arc length. Knowing that the perimeter of a circle is equals to 2 pi r, I know that the perimeter of my quarter circle would just be 1 quarter times 2 pi r. Alright, and now I'm going to fill in the digits. Alright, 1 quarter times 2, and pi would be 22 over 7, and I know that my radius is 7. From here, what I can do is take my 1 quarter times 2, that would be half, and my 7s can cancel out, and that would be 22. And from here, I know that the perimeter of my quarter circle is just 11 cm. So now what I want to do is to label it on both my quarter circles. Alright, now to look at the perimeter, which is just the outside of the figure. The outside of the figure. So my perimeter of the figure consists of 11 cm. Starting from over here, I'm going to draw my white flag over here. Starting from 11 cm plus 7 cm plus another 11 cm plus 7 cm plus 7 cm, and lastly plus 7 cm. And if I add all these together, I will have 50 cm, and this is the answer for question 14. Alright, moving on to the last question of booklet A, question 15. Let's jump right in. Mrs. Lim bought some pears and oranges and packed them into 2 bags. Alright, this is my sentence number 1. Alright, moving on to the next sentence. It says that 3/4 of the fruits were in bag A and the rest in bag B. So what I want to do is to split them up. Alright, A and B. I want to know that A, I have 3 quarters. And in B, I definitely have 1 quarter. Right, so 3 units for A, 1 unit for B. Now let's move on to sentence number 3. 4/9 of the fruits in bag A were pears. Now what do I want to do with this? I want to split A up into 9 units. Alright, so currently I have 3 units. What I want to do is to split them up into 9 units. Can you see that? Now I have 9 units. I want to label that 4/9 are pears and the rest are oranges. What I did with A, I want to do with B as well. Let's look at the next sentence. Half of the fruits bought were oranges. Now I want to find out the total number of units right now that I have in both A and B. And half of them will be oranges. So if I look at this, I have 9 on A and 3 in B. So total number of units equals to 12. And half of them would be 12 divided by 2. That would give me 6. If I have 1, 2, 3, 4, 5 units in A that are oranges, I will need 1 more unit in B to be a unit of orange. And the rest will be pears. Okay, now let's look at the last sentence. What fraction of the fruits in bag B were pears? As you can see from the model, it is very straightforward. 2/3 of the fruits in bag B were pears. And this is your answer for question number 15. Thank you.
Hi everyone, if you like this video, you can click right here for a similar video, or you can view our playlist here.